Remember, the chart, in case you're using my chart, the chart requires a product or ratio on one side and 0 on the other, no matter which one. I have to subtract 2. X plus 1 over x plus... If you said that, I apologize, I didn't hear it. My mistake. Sorry about that. Okay, now what? And no, please do not say multiply both sides by x plus 3. That is never allowed. Because x plus 3 could be positive or negative. It could be even 0. Never multiply both sides of an inequality by, in this case, x plus 3. Say it again. Yes. Write 2 or 2 over 1. Yes, very good. Why am I doing that? Perfect. So the least common denominator is, what does this need? As we know from a long time ago, what do I have at the top? Careful. X plus 1, I have to multiply it by negative 2. Minus 2x minus 6. Remember, it's minus 2x, negative 2x. So then the top becomes now excellent. Now this is chart ready. The first row, negative x minus 5. The next row, x plus 3. And what will be the last row? Exactly. Good. So then, x can be anything. What is the 0 for the top? Careful. Yes, but positive 5, negative 5 minus 5 would be negative 10. Yes, negative 5 is for this, and for the other one? Very good. Negative 5 and negative 3. There must be a 0 for each row. Where is the 0 for the first row? On the negative 5. Where is the 0 for the second row? Obviously. So what will I write on the negative 5, please? Excellent. What will I write on the negative 3? Good. The first one has a negative leading coefficient. Number 1 or number 2? Yes, number 2. So it comes from for the second one. Number 1 or number 2? Number 1. So where it's coming from? I see I have 3 subintervals. I only count the negatives. On the first subinterval, how many negatives I have? In the middle subinterval. And in the last one? Good. Now, I look here and I make a decision. X in the interval. Please remember, this is a crucial point I'm making. You cannot multiply both sides by anything that has x, unless you are told x is only positive or x is only negative. So you know when to switch the inequality symbol. Okay, good. So we're done with chapter 3. I would like to start chapter 4. I think chapter 4 is one of the most exciting in case, and I hope at some point in time you'll say that math is exciting, of this course. You saw a very interesting application of rational functions a minute ago, right? With the pH level. I take sugar and then what happens is modeled by a rational function. Powerful. But this chapter presents two functions that are even more powerful, in my opinion, than rational functions, and they are called exponential and logarithmic. Exponential and logarithmic functions. In the previous chapter, we looked at polynomial and rational functions. The reason why these were together is because they have some common areas, but they were not inverses of each other. This is a chapter in which the exponential will be proven to be the inverse of the log, and the log will be proven to be the inverse of the exponential. So these two functions are inverses of each other, meaning if to an exponential I apply log, what do I get if they are inverses of each other? To the exponential I apply log, and I get what?
0. One.
Oh.
Oh,
Exactly x. They must, if they are inverses of each other, right? To exponential, when I apply log, I get x. And to the log, when I apply exponential, I get x. That's the inverse property. I should say that the property of inverse functions. You had this as the extra credit problem on the previous test. And this is the property of inverse functions. Okay, so let's start with the exponential function. See how it looks, why, and how we graph it. So 4.1, exponential function. It's a very powerful function. The exponential function gets involved in when you get a mortgage, when you get a loan for your car, or a loan for anything. An exponential function is involved in the calculation of your monthly payments. When you put a turkey in the oven and you take it out after I don't know how many hours and you put it on the table, its temperature will decrease using a log function. Something very sad, when people die, their time of death is estimated based on a log function. Bacteria grow exponentially, so that's an exponential function. Populations like rabbits, mice, they all follow an exponential function. And it's, as I said, it's very powerful function. It's everywhere in real life situations. Okay, so how does it look? First of all, it's called exponential because the variable is the exponent. So f of x, so x is the variable, is a raised to x. A is a constant, given a constant. So this is what we call the exponential function. Now there is a problem here, and here's the problem. Can I raise 3 to negative 2? Yeah, it's 1 divided by 3 squared. Can I raise 0 to the 4th power? What do I get? 0. Can I raise 1 to the 3rd power? And I get 1. Can I raise negative 2 to the 4th power? And I get 16. Now, here's the problem with the exponential function. This is not allowed. This is not allowed. This is not allowed. And you can say, and I will have to agree with you, why? Or you can ask why. I can raise 0 to powers. I can raise 1 to powers. I can raise negative numbers to powers. If we allow these three as a possibility, then this function cannot be defined. It will not exist. Therefore, we have to limit or restrict the base. Well, I'm not talking about x. I'm talking about the base. The base can be only one of the following two options. A, in the interval 0 to 1, not 0, not 1, and not negative. And A can be between 1 and infinity. One more time. Not because we cannot raise 0 to powers, whatever we want, or 1, or negative numbers. No. The problem is, if we allow the base to be 0, 1, or negative, then we will never be able to define this function. It's inverse. So these are the only options. And we're going to look at two different situations. So let's look at f of x equals 2 to the x. In parallel to f of x equals, let's say, 1/2 to the x. Can anyone tell us which categories they come from? The first one. Does it come from the first category or the second category? The way I wrote them. Right? It's in the second one, right? Because the base is greater than 1. Now, I know you know the answer, but where does this come from? From the first category, because the base is a little number between 0 and 1, like 0.5. Okay. So let's see the differences between the two. And the graphs. Of course, they will have different graphs. Now, what do you think the power can be? Because I need to find the domain in both cases. So the question is this. What can I plug in x? Can I put 0 in here? Remember, the restriction was only for the base. Yes, 2 raised to 0 is 1. Can I put here negative 2? Yes, 2 raised to negative 2 is 1 over 2 squared, which is 1 over 4. Can I put 5 in here? So what is the domain of this function? All real numbers. Very friendly function, no problem there. The same thing on both sides. Having said that, I would like to create my chart. Negative infinity to infinity, no problems, friendly function. I'm going to pick some numbers. I'm going to pick negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, 1, and 2. And I'm going to ask you to plug in negative 2 and tell me the answer, and I will write it down. Yes, very good. 1/4. I agree. When you plug in negative 1, what will you say? Very good. When you plug in 0, when you plug in 1, when you plug in 2, excellent. Now, bear with me. We have never done this before. Okay, and we have never seen this before, unless you took this course before, which is fine. This is not the way we determine the end behavior for polynomial functions or rational functions, but this is applicable here for the exponential function. So tell me where I'm going when I go this way. 4, 2, 1, 1 over 2, 1 over 4, 1. Thank you. What does this mean? When a function on one side approaches y equals 0. What does this mean? I already said it. Y equals 0 is, yes, at negative infinity only. We have never seen this before. we looked at rational functions that have the same horizontal asymptote on both sides, right? But this one says only at the, okay, let's go the other way. 1, 2, 4, 8, 16, 32, 64, 120. Where am I going? Excellent. So let's graph this, and then we come back to the other one. Okay? Ready? What is the first ordered pair that you will tell me to plot? Very good. Excellent. Right here. Kind of hard to plot, but you know what I mean. -1, 1/2. 0, 1. 1, 2. 2, 4. Here it is. As you see, it has y = 0 horizontal asymptote at -infinity only. So this is 2 to the x. This is the graph of 2 to the x. So it has the fastest growth possible. Not even a polynomial function can do this. Polynomial functions do this. This is the fastest growth possible. Okay. Now, what can you say about this function other than domain? Range. What is the range? Excellent. Is this function increasing or decreasing on all its domain? Is it 1-to-1? Of course. Does it have an F inverse? Can I graph it? I have no idea what the F inverse is, but can I graph it? How? Exactly. I reflected with respect to which line? I reflected with respect to y = x. Please give me a few ordered pairs that I could plot so I can graph its inverse. Careful? Yes. 1/4 -2. 1/2 -1. Excellent. Excellent. Good enough. Here's the graph. Here's the graph of F inverse. It will be denoted by log base 2 of x. The inverse function is denoted by log base 2 of x. I want to see the other side now. We will define this later. If you have questions on that, just hold on. Hold off to that. Okay, good. So please plug in -2 and tell me what to write. Remember, on a fraction, a negative power flips it. Say it again, I'm sorry. 4 indeed. Please plug in -1. 2. Please plug in 0. Please plug in 1. Careful. And please plug in 2. Very good. I'm going that way. 1, 1/2, 1/4, 1 of course. So then y = 0 horizontal asymptote at infinity only. Let's go the other way. 2, 4, 8, 16, 32, 64. Okay, very good. We are ready to graph it. Which ordered pair will you tell me to plot first? Very good. Then, good. Then, yes, and so on and so forth. And this is the graph of 1/2 to the x. What is the range of this function?
0 to negative.
0 to? Good. And is this function increasing or decreasing on all its domain? So I forgot to mention here, y equals 0, HA at infinity only. So is it decreasing or increasing? Always decreasing on the entire domain. And then is it one-to-one? By the horizontal line test, it's one-to-one. Therefore, it will have an inverse. Can I graph its inverse? It will have to be symmetric with respect to y equals x. Can anyone give me some points so I can plot the inverse? Yes, 4 comma negative 2. You said 2 negative 1. Yes. And this point, whatever that is, it will not go anywhere. It has to be part of both functions. Okay, so this will be log base 1/2 of x. And we'll talk about it when we get to that. Okay, I have 10 more minutes. On page 452, bless you. I would like to graph the function 29 on page 452. Age of x equals 2 raised to x plus 1 minus 1. And you can say, what is this? Well, this is transformations on what base function? The base function is? 2 is not a function. You could say, yeah, it's a horizontal line. I'm sorry? What is the base function here that was used to determine h? There is nothing squared. I don't see anything squared. So if I had something like this, then I would have said yes. X squared was used. What was used here?
X plus 1.
Okay. Which function was used? Of course, the exponential function. The base function is 2 to the x. Excellent. Very good. That's what we're discussing, right? We're not talking about linear functions now or quadratic, right? Okay, so number 1, what transformation is first on the base? Very good. 2 to x plus 1. When I change x into x plus 1, what happens to this function? Moves to the left 1. Very good. It's a left shift of 1. Perfect. Now number 2. 2 to x plus 1 minus 1. What does this do? Very good. Down 1. Good. We have to add these two functions to our list of functions. Remember the linear, quadratic, so on and so forth. Radical, square root. Perfect. So then when I'm asked to graph this using transformations, I will graph 2 to the x. How do I graph 2 to the x? Is it increasing on all its domain or is it decreasing on all its domain? Yes. Base greater than 1, increasing on all its domain. And I know it crosses at 1, 0, comma 1, right here. So this is 2 to the x. You told me to shift this graph where? To the left one. This point from 0, 1 will move where? Exactly, negative 1, 1, correct? So then this is the new graph. which is 2 to x plus 1. Then you told me to do something else to this. Right. Remember, this graph has a horizontal asymptote. Indeed, only on one side, which we've never seen before, but it's still there. When I shift the graph, what has to shift first? The horizontal asymptote. Where will it go?
0.
It was at 0. It will have to go at -1. And now please show me how to shift, or tell me how to shift this graph down 1. This graph has to shift down 1. Exactly. This point moves right here. I don't know exactly where it's going to cross the y-axis, but it has to be this. It can be a little bit higher, I don't know. So this is the graph using transformations of 2 to x plus 1 minus 1. I would like to look at the problem, word problem 65. So you can see the applicability of this function. India is currently one of the world's fastest growing countries. Its population, it grows exponentially. It uses an exponential function. By 2040, the population of India will be larger than the population of China. By 2050, nearly 1/3 of the world population will live in these two countries alone. The exponential function, a lot of effort was put into this. 574 parentheses 1.026 parentheses are not required here, but that's fine. Models the population of India, f of x in millions, and x years after 1974. X equals 0 represents 1974. Substitute 0 for x, and without using a calculator, find India's population in 1974. So in the first question, I know I have 4 minutes left. I'll stop in 4 minutes. So I'm asked to find f of 0. So please tell me, how much is 1.026 raised to 0 power? Right, is 1, so 1 times 574 is 574 million. This was part A. Part B. Substitute 27 for x and use a calculator. Okay, so in that case, in y equals, I will clear what I have and I will punch in 574 in parentheses 1.026 and caret and x. And then I'll go to second and table and punch in 27. 27 years after 1974. It appears to be 1147.9 million. So f of 27, 1147.9 million. And that's the year 2001. In 2001. Okay. Find India's population to the nearest million in the year 2028. In 2028, I subtract 1974 from it. What do I get? So I get 4 and I get 5, 54 years. Okay, so f of 54. Go back to my chart because I have the function. All I have to do is just punch in 54. And I get 2295.5 million. Then finding this population to raise million in the year 2055. And what appears to be happening to India's population every 27 years? Okay. So 2055 is it? X equals 81? Perfect, thank you very much. So I punch in 81. And I see 4590.4. So F of 81, 4590.4 million. So according to this model, we're asked, last question, part E, what appears to be happening to India's population? As you see, this is an exponential function with a base greater than 1. So it's an increasing function, and with 574 original in 1974. So what appears to be happening? 1147 roughly times 2 is 2295, which times 2 is roughly 4590. So every 27 years, in 27 and 54 and then 70 and then 81, according to the model, what appears to be happening to the population of India? It appears to be doubling. It doubles every 27 years. So I doubt that I can finish everything on